everybody, and welcome to this edition of the Research Files. I'm Gary Waddell. Tonight we'll talk about the discovery of a very old jawbone, find out how Daniel Garrity plans to use his $330,000 grant from the EPA. We'll take a look at what UNLV is doing with robots and drones, and we'll hear how researchers on campus are looking at the bacteria that causes dysentery. A lot to get to. First, though, I want to start the evening with Vice President of the Office of Research and Economic Development, Tom Piota. Tom, welcome.
Hi, Gary.
I understand there's a new partnership between the Air Force and UNLV.
Yeah, it's great to be working with the Air Force and locally here with Nellis. It's a partnership where we're taking one of our technologies from the university. It's a great collaboration of our faculty in kinesiology, Dr. Janik Dufek and Dr. Mohammed Terbiya in engineering. They developed a foot insole that we're going to be working with the Air Force on, and it detects diabetic ulcerations. And this is particularly sensitive, to people that are diabetic and ulcerations that develop in their feet. So they've developed a foot insole that detects that and the early onset of that. So now they developed it in the lab, and now the next stage is really taking it out there and having people use it and try it out. So there's about 100 people at Nellis that they're going to use this on and try it out on, and we've got approval for that. And it's a great partnership to be able to work with Nellis on this.
Good partnership, a good person base for that too. That's
yeah,
great.
Absolutely, yeah.
We have a postdoctorate student on this on the program tonight. What is a postdoctorate scholar, and what do they do here?
Right, so postdoctoral fellows really at the university, it's kind of, we have undergrads working on research, we have graduate students working on research, we have faculty working on research, but postdocs are kind of in between a graduate student and a faculty working on research. They've finished their PhD, so they've got a doctorate, but now they've advanced on to the next stage, and we have them work with our faculty on campus here. They're full-time working on research. They can write their own proposals sometimes. They're fully funded to do research. They're incredibly valuable to help advance research at the university. As we look to become a top-tier institution, we want more postdocs. We have about 30 here on campus right now.
I was reading some of the resumes. It's amazing.
Oh yeah, they have great resumes, and they're really a valuable part of the campus. I was actually a postdoc for 2 years after I graduated with my PhD at UCLA, and then I got a faculty position after that. So it's a great transition after people get a graduate degree, and then if they want to continue that further, many times they continue as a postdoc.
Very good. Tom, thank you very much.
All right.
All right, we got a lot to do tonight. Stay with us. We'll be right back.
At that moment, it hit me. This is why I joined the Guard. I couldn't believe it. I just saved the life of somebody from my hometown. Be there for your community at NationalGuard.com.
Welcome back. Joining us now is Paul O., Lindsey Professor for Unmanned Aerial Systems in the College of Engineering. Welcome, Paul. Thank you for being with us.
Well, it's been an honor. Thank you very much, Gary.
Your resume says that you are a internationally renowned expert in unmanned autonomous systems research. Lots of big words. I mean, I have an idea what it means, but what does it really, what are your duties?
Well, in short, I build robots.
Very good.
Right, and I enjoy doing it, and I think robotics is a very exciting future.
Robots that look like human beings, or robots that look like the Tesla plant?
That's a good question. For me, they're all kind of one and the same. Some walk, some fly, some swim. Some are stationary. So to me, that's why we call it an autonomous system.
Drones seem to be changing the world out there.
That's what they say. It really captures the imagination to be able to fly and do so robotically. And we're particularly interested in using drones for disaster response.
You were hired in 2014, charged with the task of establishing a UAS lab with humanoid robots and fleet of drones. Where are you in that process?
Well, we're excited. We have a space that's just across Maryland. It's actually near the Las Vegas Clark County Library. It's a very nice space, and we're working with planning and construction to make it a world-class research center.
If we go by the university now, do we see your drones flying?
No, you actually have to go inside. We do a lot of flying indoors, because for us, designing disaster response drones requires us to fly indoors through caves and tunnels and things like that.
Oh, okay. you know, it seems really exciting when we look at it. I mean, I come from the news business, and we look at drones as news gathering tools, but there really are a lot of other uses for drones, aerial drones, right?
Absolutely. So some of the research that we've done was in creating this medevac drone. You know, is be able to, you know, find casualties and extract them and bring them back to like MASH units or Navy hospitals.
Really bring people back on a drone without.
Right, especially things in, for example, a mountain rescue, or if it is a disaster where it's just too harmful to send people. We like to send out these robots to be able to assist and help with that.
Seeing a huge forest fire burning in Canada right now. Is that something drones could eventually be, even if it's used only to map it or things like that?
Yeah, we actually hope that it could help with the first responders to be actually put out the fire.
Wow. You took a group of students to the, is it DARPA Robotics Challenge last year?
That's correct. That was unprecedented, you know, world-wide you know, gathering of roboticists for disaster response.
How did you guys do?
We did wonderfully. Actually, the robot that won the first place is the same model that we have in the lab. That was co-developed with my cousin in Korea, actually.
Oh, wow.
So they got the $2 million prize, and I'm waiting for my cut. But, you know, he had, their team had about 12 months head start before we did. We placed in the top 10, and I'm very happy to say that we beat out, you know, places like Lockheed Martin and others.
Very nice, very nice. You going back?
Well, yeah, you know, DARPA Grand Challenges are the epitome. They don't happen every year, and they kind of use that to set the needle as to where we need to put our, you know, taxpayers' money into research and to be able to advance the field.
Paul, fascinating work. Thank you so much for being with us.
Thank you very much, Gary.
Okay, we'll be right back. With me now are Helen Wing, Associate Professor of Molecular Microbiology, and Natasha Witherspoon Griffin, a postdoctoral scholar in the School of Life Sciences. Welcome to both of you. Thank you very much for being here. You were doing research into dysentery. First, let's talk about that. What is it? How deadly is it? Who gets it? What symptoms does it produce?
Well, first of all, thanks for the opportunity to tell you about our research today. Diarrheal diseases kill 1 in 9 children worldwide, and Shigella contributes significantly to these sobering statistics, causing over 1.1 million deaths per year and 195 million cases of this disease worldwide. Now, most cases occur in the developing world, but here in the United States, it's estimated that upwards of 200,000 cases occur each year in the United States. Sometimes these are connected to international travel. Other times these cases are associated with daycare settings or elementary school settings. For instance, just last year, there was an outbreak of shigellosis in Kansas City, Missouri, and there were 150 cases reported. Most of the afflicted people were children under the age of 6.
Wow.
Now, when the bacterium was looked at, it was found to be resistant to multiple antibiotics, and so this really demonstrates the need for maintained vigilance here.
So how is your research going to change that? I mean, what are you looking at specifically in treating, dealing with it, preventing it?
It turns out that there's a particular set of genes in Shigella that make it as virulent as it is. And these genes are not always active. In fact, they only become active once the bacterium is ingested into the human body. So we hope to understand what the environmental cues are, what the molecular events are that trigger that set of genes to become active so that we can interfere with that process, decreasing the symptoms of the disease and helping people recover more rapidly.
Wow. spoke earlier the role of, we talked earlier with Tom Piota about the role of postdoctoral students at UNLV. Tell us about your postdoctorate position at UNLV.
Well, sure. First, I'd like to say that a postdoc position in any life science or career is really important. It's a very important stepping stone. For me, I was able to develop an independent research project, gain insight into various funding opportunities, and actually apply for funding sources. And I've also been able to continue to share my research with the scientific community and with the public like we're doing today. But in addition, I also had the unique opportunity to consider various different career paths that aren't necessarily thought of as traditional paths. And with the encouragement and the guidance from a mentor, I've been able to kind of hone in on a career path that's best suited for myself.
So where are you headed?
Right now, I'm still in academia, but the world's still open.
College professor, maybe?
Perhaps. I'm keeping all the doors open.
You seem to have a good mentor here in all of that. That's good. You were awarded a UNLV-sponsored Faculty Opportunity Award. How are you going to use the award?
Yeah, we were very excited about that. So back in 2015, Natasha and I filed an invention disclosure. So I don't want to give too much away here, but suffice to say that the ideas contained within that invention disclosure stem from work that Natasha did directly in my research lab here at UNLV. Now, of course, in order to continue our research, to develop our ideas more, we need research dollars. And fortunately for us, our FOA application was selected. So UNLV will be providing a small but significant injection of cash to get our research moving forward so that those patents and hopefully new types of vaccines can be developed.
An injection of cash to get an injection of cure or prevention. So do you see yourself as role models for women who are aspiring to be scientists?
You know what? I never really considered myself a role model, but I can see how I can be considered one. With that said, I like people to know that I didn't always know what I wanted to do. It was actually the guidance of great mentors along the way that allowed me the opportunity to find out what I liked and then ultimately what I loved, which is research in microbiology. So I like to encourage anybody who's unsure about their future to keep an open mind because it might surprise you where you end up.
So Helen, do you tell women who come to you and want to be part of this that it's a really great career?
Yeah, and in the School of Life Science, we have a demographic of 60% women, 40% male at both the undergraduate and graduate level. And I sit on many graduate student committees, about 10 actually. And for those students that I don't mentor directly, 100% of them are women. Wow. So I'm very proud of that, and that demonstrates, I think, that I'm serving a good role as a mentor for aspiring female scientists.
Very good. Ladies, thank you so much.
Thank you.
Good luck with your research and with your future and with all that you guys are doing here and mentoring for the more students in the future.
Sure.
Thanks a lot. Don't go away. We'll be right back.
DAV stands behind America's veterans to make their transition back home easier with free services and help getting the benefits they've earned. Help us fulfill the promise to our men and women who served. Go to DAV.org to learn more.
We are pleased now to be joined by Brian Villemore, Assistant Professor of Anthropology. He made an amazing discovery in Ethiopia. First, tell us what you found and why it's important.
So this is the first evidence of our genus. We are Homo sapiens, and this is the earliest specimen of that genus, so we call it early Homo. The reason it's important is because prior to, let's say, 3 million years ago, humans were essentially ape-like. And after 2 million years, we know that they are human-like. They use tools, and they're upright, they're no longer in the trees, they're living in an open environment. But there were no fossils from about 3 to 2.2 million years, a big blank spot in the map. And so this was the first piece that fills that gap.
And you know that's about, what, 2.8 million you're saying years old? And how do you know that?
Well, when a volcano erupts, the ash settles in the dirt, and the ash can be dated. So this was found between 2 ash layers, and the bracket between those 2 ash layers is 2.8 plus or minus 20,000 years.
Wow. So this is really, I mean, this is like the best finds of ever of archaeologists, right?
It's pretty important. It establishes the trajectory towards the modern lifestyle, dependent on large brains and tools.
This is a cast model, obviously. You're not walking around with the real thing in your pocket. Where is the original?
Well, it's the property of the government of Ethiopia, so we keep it in the National Museum in Addis Ababa.
Wow. You were part of an international team. How does it feel to do work like this? What kind of rush do you get from this?
Well, it's the highlight of our year, obviously, to go out there and do this. I've always liked the outdoors, and in fact, I picked this career partially because I could spend time living in a tent in the middle of the desert.
You made the find of a lifetime.
Thank you.
Is it all downhill from here now? I mean, you're going to go back, you said.
No, we go back every other year, actually. So we went back in 2015, and we did find some more teeth of the same species, presumably, and we're hoping to find more. So there's one big hill where everything seems to erode out, and we're going to go back to that hill and pour over it.
Are there other places? There probably are other places in the world that are obviously, I mean, that are going to have things like this, but we don't know where they are. I mean,
that's right. You just have to. I mean, it took us 10 years to find this location.
how did you find the location? What brought you there in the first place?
Well, it's an area that's known for a lot of fossil discoveries. It's only 50 miles from where they discovered Lucy. So if you know that fossil, that's about a 3.4 million year old early human. So we know it's fossiliferous, but there's no substitute for just walking day after day after day through the desert with your eyes on the ground.
And is that on the surface? Is it just lying there to be found, or?
It was partially eroded out. So it was on a bit of a slope, and the fellow that discovered it, who's an Ethiopian graduate student, saw some of the teeth, and he knew that those were human teeth, so he just moved the dirt aside and called us all over.
And there it is, and that's the full size of what
Correct,
you found.
that's
exactly what you found.
Right.
It's hard to believe that something like that is as scientifically important as it is.
Sure. So part of the importance of this is actually not the anatomy. I mean, specialists appreciate the anatomy, but it's really a marker for the change from an earlier group to us. So in other words, the question why we became the way we do can be answered by the other fossils that we find with this. So before 3 million years, the fossils that are non-human are wet environment fossils, so they're rainforest associated. Afterwards, you find animals like the Serengeti. So that means that part of the reason we had to evolve was because we could no longer live in the rainforest.
Wow. Brian, thank you very much. Fascinating stuff.
My pleasure.
Good luck on your next trip back.
Thanks.
Okay, thanks. We will be right back.
Drownings are a leading cause of death for young children. Make sure kids learn how to swim. Always watch them in and around water and properly fence all pools. Simple steps save lives. To learn some new ones, visit poolsafely.gov.
Welcome back. Our next guest, Assistant Physics and Astronomy Professor Jason Stefan. Thanks for joining us. I know you do a lot of exciting work and research in astrophysics. We'll get to that in a minute. But first, there is the Stefan method for loading an airplane.
Yeah, so that was
Tell me about that.
That was a project that sometime over Christmas holidays I needed something to do and was kind of bored and had been thinking about it for a while, so I decided either I need to stop thinking about it or I should solve the problem and see what the answer actually is. And it turned out that it was a bit more surprising than I'd expected,
Really?
but it boils down to the fact that when people get onto airplanes, kind of the traditional back-to-front method, which was obviously the best way to do it, at least beforehand, you end up trying to get everybody in the last row into the airplane at the same time, and they just get in each other's way because they're all trying to sit in the same part of the airplane. It turns out that the fastest way to board it is to spread people out so that they're sitting all over the airplane, and then everyone can put their luggage away at the same time, and everyone can sit down at the same time. And you change it from like a serial process into a parallel process where everyone who's on the airplane is doing something besides waiting for the person in
So
front of them.
row A, row 1, row 10, row 15,
Right.
row 20 as the first loaders.
Right, and you can get them as close together as every other row, so you could have
Really?
1, 3, 5, 7, 9 in reverse order so that the person goes to the back and then 15 people sit down at once.
How has this been taken by the airlines? Anybody going to do this yet?
I'm still listening to the sound of silence, but
Yeah.
I know it's spawned some interest internally, at least in some airlines.
It won't work on Southwest because they just everybody get on wherever you want to sit, you sit. So maybe that does help though in a way.
Yeah, so Southwest actually has the fastest boarding times in the industry. My method went head-to-head against Southwest on a NOVA episode a few years ago.
Oh.
And I was about 30% faster.
Very good.
But they have kind of their niche market in terms of that's the way they do things.
That's the way they do it. Yeah. Well, it's good. I hope that catches on. That'll be very nice. And what a feather in your cap if it does. You've been part of the NASA Kepler mission since 2008. Tell us about the mission, what they're looking for, and how it's going.
Right, so the Kepler mission is a mission from NASA where they're looking for exoplanets. These are planets that are orbiting stars other than the sun. And the way it does it is it takes a picture of those stars every 30 minutes, and it did that for a period of 4 years, every 30 minutes taking a picture. And just like today was a transit of Mercury, where Mercury was passing along the line of sight between the Earth and the Sun. And so you could actually see Mercury's shadow, or basically the equivalent of it, the dot of Mercury going across the Sun. And Kepler does exactly the same thing, except this is around other stars. Kepler's found something like 5,000 really good planet candidates orbiting these other stars, and so I've been doing research studying the properties of the systems, how the planets are arranged, what their sizes are with respect to each other, where they live in orbital period, and so forth.
I was just thinking about, we were talking a minute ago about the Earth, and what a just a amazing coincidence of events that made this planet inhabitable by human beings like us.
Yeah, the Earth is really quite an amazing thing if you think about it. There's a lot of things that contribute to its habitability. A lot of it, we're not totally clear if it's essential for habitability or if it's just something that facilitates it. But on the Earth, if you were to take all the water on the Earth and spread it out uniformly across the surface, it's only about 1.5 miles thick. That's about the equivalent of a sheet of paper to something the size of a basketball. And so we really do live on this really thin layer of habitable material on the Earth.
Now there's the TESS mission. What's that?
So when Kepler flew, it stared at one part of the sky for 4 years straight, basically without blinking. The TESS mission is going to do the same kind of strategy, looking for transits, looking for the planets to pass in front of the host star. But it's going to do it across the entire sky. It's going to survey the whole sky over the course of 2 years. The idea with TESS is that it's going to look for the brightest stars, because those are the ones that are easiest to follow up. They're easiest to follow up with measurements of the atmosphere. They're easiest to follow up with other ground-based instruments that you can use to detect other planets in the same system.
What's the most challenging part of your job?
Honestly, right now in the field of exoplanets, there's so much to do. One of the most challenging parts of the job is picking something from the wide variety of things to work on, picking something to work on and sticking with it.
Wow. Well, you've loaded airplanes now. Find us another habitable planet out there.
We're working on it.
Jason, thank you so much. I appreciate it.
Thank you.
We'll be right back. Our final guest this evening is Civil and Environmental Engineering Professor Daniel Garrity. Dan, thank you for being with us. We appreciate it.
Thank you for having me.
You just got a $330,000 grant from the EPA. Tell us when the money was awarded and what you plan to do with it. And my suggestion is bet it on black.
I don't know if they'd approve of that, so I'll stick to the research side. But it's been about a project 2 years in the making. We've been working on it for about a year now, so we're well into it. We have about 2 years left to go. There's 3 different parts to it. So the first part is doing a quantitative microbial risk assessment. So we're trying to figure out what's the risk of waterborne disease from different drinking water scenarios. So kind of related to what Dr. Wing was talking about earlier. The second part is looking at the life cycle assessment of potable reuse. So turning wastewater back into drinking water.
Which we do here, right?
We do here. So we do it, they do it all around the world in many different ways. So this whole project is related to the various ways that's done around the world. So if I was going to give you a bucket and ask you to bring that water from Lake Mead all the way back into the valley, it would take a lot of energy and you probably wouldn't want to do it.
Right.
So one of the things that we're looking at is if we take all that energy that you would exert doing that and we put it more into advanced water treatment and then drink that water directly rather than putting it into the lake, we're trying to figure out when that scenario makes sense. So that's the role of the second part there. And then the third part is more of a typical environmental engineering application where we're looking at a different type of treatment train to turn wastewater back into drinking water.
Obviously, moving water is very expensive. I mean, we can't bring water from the eastern slope of the Rockies over to the west economically to make sure that we have enough water here. That's got to be a huge factor that would affect people all around the world.
Yeah, it is a huge factor. So, and it's one of the reasons that this research came to be is because of that economic factor. So one of the issues with potable reuse in a lot of the ways that it's done in California, for example, is that the treatment that we use to do that is very cost intensive and energy intensive. But in a lot of cases, it's actually cheaper and more cost effective to do that rather than taking that water from other places and bringing it in. So potable reuse is kind of an alternative to what you were talking about right there.
You're collaborating with a number of other schools. What schools and how are you doing that?
Yes, there's actually one school that we're collaborating with, the University of Michigan. So the chair of epidemiology there is providing some expertise in the public health side. So when we do these microbial risk assessments, he's making sure we're doing it correctly. And then beyond that, we're actually collaborating with the Southern Nevada Water Authority here in town. So they're providing some analytical expertise for some of the samples that we're analyzing. And we're also working with a consulting firm in San Diego who's kind of become an expert in this potable reuse concept. So they're providing their expertise and related to the projects that they're working on.
We've seen a lot of news come out of Flint, Michigan. Is that part of their research too? Are they doing things like that?
In some respects, they're doing the same kind of work. So the Flint issue is more of a conventional drinking water type application or issue. But the things that they're experiencing in Flint are the same things that you would experience when you're turning wastewater into drinking water. So in all those applications, you're trying to prevent those things from happening.
You also manage the Environmental Engineering Water Quality Laboratory. Tell us about that. The work you're doing.
So I co-manage it with Dr. Jossie Batista, and we have quite a few students from very many levels. So we had an elementary school student come in last semester and work with us.
Oh,
we
wow.
have high school students come in over the summer. We have undergrads. We have grad students from all around the world. So it's a really fun group to work with.
You've been testing water. Is our drinking water here okay?
Drinking water is fantastic here.
It is in Las Vegas?
Yep, we have one of the best.
Okay, that's always nice to know. Very nice. Dan, thank you very much for being with us.
Thank you for
We
having me.
appreciate it.
Thanks.
Keep up the good work. That's going to do it for us for this evening. We hope you join us again next semester. I'm Gary Waddell. Good night.